Hi guys, welcome to lesson 9.7 part 2 or 9.7b. Today we're going to be talking about compound interest. Let's do a quick review of what simple interest was from yesterday. So you've got space for each of these problems. Go ahead and pause the video and try these, see if you remember how to do them, and then come back and we'll check our work together. So for these problems, if we're doing simple interest, we're using the formula interest equals the principal times the rate times the time. Now, this is going to be our principal. Our principal is the initial amount that is invested or borrowed. This is our rate, but we have to write it as a decimal, so it's going to be 0.0675. And then this is going to be our t value. So we've got our P, R, and T. I equals $400 times 0.0675 times 8. When we multiply all those things together, we will get $216. So the interest is $216. So for the next one, we've got I equals 1,250 times, if we change this to a decimal, we get 0.093. So multiply that in there times 4. And if we multiply those together, we get 465. All right, so that's simple interest. Today we're going to look at compound interest. And so if you haven't already, go watch this video. It's going to give you a quick intro to what compound interest is and explaining how it's different from simple interest. So if you haven't watched it, put a pause on this video, go watch this one, and then come back. But compound interest is interest that is paid on the original principal as well as any interest that has been left in the account. And this is what most banks will use. This is what most loans will use. This is the most common type of interest. Our formula is going to be that the balance of an account is the principal plus any interest earned. So principal times 1 plus the rate raised to the exponent of t in years. And so I've got this label down here. B is balance, P is principal, R is the annual interest rate, and T is the time in years. All right, so you deposit $3,000 in a bank account. That's our principal. I'm going to just start labeling as we go. It pays 4.25% interest. All right, so let's look at that. That would be 0.0425. That's our rate. And our balance after 12 years, that's our time. So I'm going to start by writing my formula. You should always do that. And then I'm going to substitute in what I know. I'm trying to find the balance, but I know that the principal is 3,000. It's always 1 plus, and my rate this time is 0.0425, and it's raised to the 12th power. Be very careful here and make sure you remember that this is an exponent. So compound interest requires a few more steps than simple interest did. So I'm going to keep this 3,000, and my order of operations, or PEMDAS, says to take care of what's in parentheses first. So if I add these together, I'm going to get 1 plus 0.0425 to the 12th power. Oh, sorry. When I add those together, it should just be 1.0425. Next, I need to raise 1.0425 to the 12th power. So remember, on your calculator, there's the little button that looks like this. So you'll do 1.0425, and then I call it a caret to the 12th power. And when we do that, sorry, I got to put it in my own calculator, we should get 1.6, I'm going to do 648. I'm going to do 3 decimals. You might only do 2, you might do 4. It doesn't really matter. I would say definitely doing 1 is too few, and doing 1 decimal after, or 1 number after the decimal is not enough either. So then we're going to take that answer and we're going to times it by 3,000, and we get 4,943.49. So if we deposited $3,000 in a bank account at this interest rate, and then we didn't do anything else with it, we didn't take any money in or put any money in or take any money out. There we go. After 12 years, this is how much money would be in our account. So we would put in 3,000, and essentially what it's saying is that we would earn $1,943.49 in interest. Pretty sweet deal. All right, so we've got depositing $500 in a bank account that pays 3% interest, compounded annually. I'm going to change up my color. So this is our p-value. We have to change this to a decimal, but we get 0.03, and that's our R, and this is our T. Writing my formula. And then substituting in what I know. 1 plus 0.03 raised to the 4th power, taking care of what's in parentheses first. So that'll be 1.03 to the 4th power. I need to do 1.03, raise it to the 4th power, and I get 1.26. And then I need to take that answer and multiply it by 500. And I'm going to get B equals $562.75. And this is the balance after 4 years. All right, try this problem, and then when you're done, come back, pause the video first, and then come back and we'll check. All right, you should have your formula written. And then substitute in what we know. We know that $5,000 is the principal. The interest is going to be 0.0375, and 9 is going to be our T. So we have 5,000 times 1 plus 0.0375, all to the 9th power. So we're going to have 5,000 times 1.0375 to the 9th power. Doing 1.0375 to the 9th power would give us 1.393. So I'm going to get that. Multiplying these two together, I'm going to get 6,964.07. And I'm going to round it to 2 decimals again. I think we talked about that yesterday a little bit. Whenever we're dealing with money, we want to round to 2 decimal places. All right, here's another one that you can try in your notes. So pause the video, come back, and we'll check our work. Going to label what I know. And this is our T value. So we're going to have back up. Got to write my formula first. B equals P times 1 plus R to the T, and B equals 2,125 times 1 plus 0.05 to the 7th power, and we get B equals 2,125 times 1.05 to the 7th power. When I do 1.05 raised to the 7th power, we get 1.407, and then multiplying that answer by 2,125, we get B equals 2,990.09. And that's it. That's all we're doing for today. So take a look at the assignment that's in Google Classroom. I'll be in Zoom if you need me, and ask me any questions. Thanks, guys.